Utopias, dystopias, and today's technologies hosted by Johannes and bringing a global conversation discussing technologies that affect us all.
Hello and welcome. My name is Johannes, and I am the host of this show. Today I'm here with Neville Newey, and we will be talking a little bit about AI, how it has changed over the years, the culture, and what data science means, and what it has meant traditionally, if there's any changes. We'll talk a little bit about some myths in AI. We'll address some myths in AI, some hype. And yes, let's get started right away. Neville, I want to introduce you. Neville is a serial entrepreneur. He has built a company called Milo that was acquired by eBay. And in 2015, he was one of the director of data science at eBay, and he hired me there as a senior data scientist. So that is our personal history as well, just to let you know about that. Welcome, Neville. It's great to see you. And as always, I hope it'll be a great discussion. And yeah, so let me just start out. Maybe you can tell our viewers and listeners a little bit more about your background in terms of how far it really goes back when you started working with AI and where you were. And I think you were in Botswana. Is that right? Anyway, yeah, go ahead and tell us a little bit about your background and your own mission or your own experience with AI over the years.
Sure, thanks, Johannes, and good to be here. I'll just start off with a small clarification. I just wanted to clarify a little bit around Milo because your words give me more credit than I deserve. I didn't actually found the company. I joined when it was already going. However, I did make quite a big contribution from that point on.
Hmm.
So to your question, going back to my history with AI, well, it I'd say it started a very long time ago before I really even knew what AI was, and I would say it started when I got my first computer. I think I must have been about 15 years old or so, and this was a Sinclair ZX81. I don't know if you're familiar with that computer, but it was made by Sinclair Corporation. I believe they were a British company. And a friend of mine, and this is before the internet, so a friend of mine used to get these electronic magazines from the UK. This was in South Africa. And in it was an advertisement in the classified section at the back for this amazing new first sort of home computer that came out, and it was about £300 at that time. It came with 1 kilobyte of memory, so just over 1,000 bytes of memory.
What was the year roughly?
That would have been around 1982, I believe, around 81, 82. You can look up the
Hmm.
ZX81. It was actually the second one in the series because they had a ZX80 before that. In fact, 81 probably referred to the year that it came out.
I see. Yeah. Okay.
A-
Yeah.
Anyway, he ordered this computer and he told me he was very, very excited. And he said, "This thing is being shipped to me from the UK." In those days, it took about 6 weeks for things to come. I did not even know what a computer was at that point. I knew what a calculator was because my father had a HP calculator.
Hmm.
So I assumed it was some sort of a calculatory type thing. Anyway, the day it arrived, he invited me over to his house, and I went there, and we were very excited. And we unpacked it. You had to plug it into your TV, and it had the unit was really a keyboard, and it had the chip inside it, and it the operating system was not much to speak of. It was basically a basic environment, as in basic the programming language. So when you
Yes.
booted it up, you went into a prompt inside a basic interpreter, and then you could start typing in programs. So in fact, the very first we read the manual, and we sort of got an idea about what the different sort of keywords in the basic language meant. And the very first program we created was a chatbot.
Oh, wow.
So it was extremely simple. It was no more than about 15 lines of code, and it was something like print, "Hello, I am a ZX81 computer. What is your name?" And then get inputs, and then how are you, blah, and we didn't realize it at the time, but that was essentially an extremely primitive chatbot. But that little episode got me thinking immediately from the get go about the possibility of sort of synthesizing human thought and human logic and getting machines to behave in some sense like a human. And that was an instant fascination for me, which follows me, to this day. And that was probably 36 years ago, something like that.
Oh.
So that's sort of the very far back history, and maybe as we go along, I'll throw in other bits and pieces.
Have you seen that movie that was actually not too much later than that, called 20 Minutes into the Future, Max Headroom? Because that was, I think, also extremely early and extremely prescient.
Still alive out there? Good. This is Max Headroom.
I don't know if have you seen it?
I have not.
Yeah, okay. I think it was like 1985. So it was my first encounter. Although I didn't see it in 1985. To be clear, I saw it in the 90s, like early 90s or something like this, because I
Yeah.
wasn't, I was nowhere. I wasn't even really a functioning human being in the sense, in the 80s. But in the 90s, I saw this movie from the 1980s, from the 1985. So it's called 20 Minutes into the Future. It's actually incredible because there is somebody making a digital twin of a reporter whom they wanted to disappear. So they wanted to disappear this reporter, and but they didn't want his show to go away, so they tried to generate a digital twin of him to keep him alive. It's a really wild thing. Later on, he became this character became a spokesperson for Coca-Cola, which is actually the whole thing is quite punk rock.
Is this a private party or can any store crush? So, Coke is irresistible. This is more modern than. You said the P word. So, what I want to know is, if you're drinking Coke, who's drinking Pepsi? If you can't beat it, catch the wave. Coke.
The whole thing from beginning, it's quite fun and interesting to watch. But anyway, yeah. So then what happened? So what did you do with this knowledge, and where did you go from there? So when did you actually build something? I understand, that you got into statistics and into machine learning, I suppose. When did that happen, and how much of a journey was it from the 1981 experiment?
Well, from that experiment, I convinced my father that I also needed to have a ZX81. So eventually, a few months later, I also got a ZX81, and I started to code on it. And at that time, these magazines that we used to get, they used to get programs in the magazine, and you'd have to type them in. So the magazine would come with a printed basic program, and then you could type it in and run it on your own machine. And shortly, very quickly, pretty sophisticated programs started coming out. We're talking relative here, because remember, this machine only had 1 kilobyte of memory. And believe it or not, drafts programs, there was even a chess program came out. So AI sort of games started coming out very early, and you could save your programs to a tape. So you plugged in a tape recorder, those old cassette tapes. That you know, that's how you saved the program. So I started developing. I started developing my own programs, and I started developing a drafts program and a few other games and so on. Um, anyway, it kept up my interest in this. You could also, by the way, the way they managed to get more into that 1 kilobyte was you could actually type in machine code itself. So not only basic, there was a way to sort of type in strings that were machine code, and there was a keyword in the basic interpreter that allowed you to load that directly into memory and then force the computer to run the actual machine code. There were no debuggers or anything like that, so it was, extremely brittle process. Eventually, I upgraded to a VIC-20, what was called a VIC-20, which was a Commodore machine, and that had 3.5K, and the luxury of going from 1K to 3.5K, it was unbelievable. you know, Suddenly had 3.5 times as much memory, um, and it had colors. The ZX81 did not have any color, so VIC-20 actually is color, and you could write more memory. And then I managed to convince my father to buy me a 16 megabyte memory add-on module that you plugged into the back of the VIC-20. So now I had 19.5K, and it seemed to me at that time that I would never use all of that. It just seemed like so extravagant.
Just for perspective, how much memory does your brand new Mac have right now?
Well, I took the smaller option, which has 16 gigabytes. My my cell phone right next to me has 128 gigabytes. So, yeah, so it is, Moore's law and all of these things are sort of pretty crazy, and perhaps we'll start touch on it a little bit in this podcast. But quantum computing is going to be the next sort of big wave. But I don't want to jump too
Well,
far
have you
ahead.
have you done any forays into quantum computing actually? Do you know, have you worked in that field?
No, I have not. I've sort of been following it, and again, I'm fascinated by it, and they're going to have to be a different way of thinking of programming, because you now, are able to compute things simultaneously. So it's going to require a huge paradigm shift in the way that we think, and the way that programs are executed in algorithms. Really, the algorithms are going to be completely new. I'm still a little bit skeptical that we'll ever actually get there. You mentioned hype early on. There is quite a bit of hype surrounding that. There are companies who have claimed to already have built and are indeed sell. You can indeed buy a quantum computer today, but it is, from my understanding at least, it's extremely limited in what you can do, and it's not really truly quantum, in the sense that it's running purely on qubits. I believe qubits have been created, single ones, and maybe even more true qubits, but to the extent that the technology is available to have a purely quantum MacBook on your lap is I think is very, very far away, and I'm a little bit skeptical that we'll ever get there.
Interesting. But let's
Bec-
go a little bit back to what this all of this stuff, just to recap on this 80s stuff. that was all before, or was it during the AI winter? And could you say a little bit about the AI winter? What is this term? What does it mean? Why was it there? And why was it overcome? Why is there now no more AI winters?
Well, I'm not sure exactly which era you're referring to, but if I think of the term, it certainly seems applicable to definitely that period. So even before the 80s, of course, there were people at MIT and so on who were doing research into AI, and mostly in sort of symbolic processing. I think Marvin Minsky and others were experimenting, but it was largely symbolic processing using programming languages such as Lisp and so on. And then really, I think I know we're going to get onto sort of ChatGPT and those type of things later, but one of the sort of milestones came a few years later, I think, when neural networks really sort of came onto the scene. And in my recollection, that would have been probably, I don't know exactly when the first concept of a neural network was proposed, but it was probably around that same period, 80s, maybe even before that. But I do remember. So subsequently, I went to university, studied computer science. I became extremely disillusioned by academia, so I quit quite early on. I think you had a similar experience in your life, and anyway, I ended up working at in South Africa what is called the CSIR, which was the Council for Scientific and Industrial Research. They actually had sponsored me to go to university, so the deal was part of them paying my academic fees was that I had to go and work for them afterwards. And at that time, there was a lot of hype coming out about neural networks. And I got placed in a team of engineers. These were electrical engineers. Actually, they were actually interesting groups studying underwater acoustics. And I was the only computer scientist in the group of about 15 or so of these electrical engineers. So they assigned all the programming to me, and they had heard of neural networks and they were intrigued by this idea. So they said, "Okay, code a neural network to solve our problems." uh, so
What year was that
yeah,
roughly?
again,
Just to keep
that
chronological.
that would have been about 19, let's see, 87,
Still
88,
in the
around
80s.
that time. Yeah, but by that time we did now have personal computers, or what I would call the standard personal computer, which was originally based on the IBM computer, but the ones with the Intel chips, and I think Windows version 1 or 2 or even Windows version 3 was out then. Anyway, I started coding neural networks. Using coding. There were no tools available. Python probably didn't even exist yet. So everything in those days, I used to code everything in C. So, and there were no sort of packages or tools that you could use off the shelf. So you had to code everything from scratch. So I coded up this neural network, and for the life of me, I could not get this thing to converge. The training weights would never converge. It just appeared to do nothing, and it took me, and it always perplexed me. And it was only years later when I became more involved in the actual mathematics of these things that I suddenly realized why my damn neural network had never ever converged. And it's because I was a hacker. And you'll see any tutorial on neural networks will say, set the initial weights to some random number close to zero. So me being a lazy hacker said to myself, well, zero is a random number close to zero. So set them all to zero.
Oh, I can see the problem there.
And then years later, I was like, "Oh, how stupid can you be?" So there's a big lesson learned there. It's good to be a hacker, but don't try to be too smart.
It helps to look up and read a little bit more about how stuff works, I suppose.
Yeah,
Yeah, that's
yeah.
interesting. So this
But,
was
but
also during the AI winter, right? So go back to that. Like,
yeah, so getting back to your winter question, so at that time, there were smarter people than me by far that didn't set them to zero and did have neural networks that kind of worked. But I believe somebody proved that, and I don't remember who it was now, you probably know, who came out with this proof that neural networks, at least as they were configured at that time, were not even capable of solving the XOR problem.
Let's look at a simple example. Remember, when neural nets first died, they died because Minsky and Papert proved that they can't solve the XOR. Okay, so that only happens when you have one neuron. Right? If you get to have more than one neuron, then you can solve the XOR problem. So remember the XOR problem. You've got 0 and 1 for the first attribute, 0 and 1 for the second attribute, and you're looking for the exclusive OR when only one of them is on. That's a positive class, and when either both are on or both are off, that's a negative class. So there's no way to solve this with just a single unit. There's no way to draw a hyperplane to separate the points. But the following network, very simple network, will solve the problem.
So this was a major setback, and all of the hype at that time about how neural networks were going to solve all humanity's problems and take over the world and put people out of jobs. Sound familiar? There was a lot of that hype at that time, but then this I believe they probably published a paper on it, came out, and it really caused everybody to say, "Oh my God, all right, forget about neural networks." That was one thing that contributed to it. The other thing was that the computing power at that time, I think, at the time when I was there working on this, you still had that maximum of 640K. I don't know where the number of 640K came from. It sounds like it's 10 times 64K, but that was more or less the maximum memory that you could use at that time. So there was limited memory, there was limited disk space, there was limited CPU power to run the training for a long time. So really, neural networks were kind of ahead of their time for the hardware capabilities, and that I think also contributed to the sort of winter. And then again, I'm not really familiar with that term, but I would say then probably the spring, the winter, the AI spring would probably be the sort of revival. I mean, we're talking now probably in the 2000s, maybe 15 years ago, when big companies like Google and others started doing a lot of their own research, and computing power had now become you know leaps leaps and bounds ahead of what we had, as we've already mentioned, and new neural architectures started coming out, and we started seeing results. And so to me, that would sort of be the spring that got us out of that winter.
and then you basically then at some point you went to America, right? At some point you went to the Silicon Valley because why did you go to the Silicon Valley? What made you go? Because you hit a roadblock, or
No, it was actually because of my son. So I have a son who has autism, and in the Bay Area, there was a lot of research going on around autism, particularly at UC Davis at the time, and the schools in the Bay Area. My son was 3 or 4 years old at the time, and the schools in the Bay Area. That was a time when the hype was that autism was really, really expanding, which I'm skeptical of, but that's a whole nother topic. But anyway, the result of it was that the schools in the Bay Area were extremely aware of autism, and each school, many schools, if not all of them, had specific programs in their school to deal with autistic kids, which wasn't available on the East Coast. So that's why I took him and went to the West Coast and to Silicon Valley. So it wasn't that I was following, AI or anything like that, although that was a nice side bonus of it. It was just purely accidental.
That's a good coincidence, I suppose. And then you had this a massive career because of it. But so let's say, okay, now if we can extrapolate and you say Moore's law and all of these things, let's talk a bit about that. Can you give our audience a little introduction to Moore's law?
Well, the original Moore's law, which was, I believe his name was Arthur Moore, was it? I can't remember. I think he worked for Intel, and the way, it's not even really a law, it was more an observation. And at the time that it first came out, I believe, and correct me if I'm wrong, but I believe he said that the number of transistors in a microchip doubled every 18 months. So that was the original Moore's law. So that's sort of the very strict meaning of it, I guess. But it very quickly came to represent computing technology in general. So not only did our chips double in their sort of internal capabilities, the memory also doubled, sometimes more than doubled, but basically it increased at a very rapid rate. Also, the speed at which the chip was clocked got higher and higher and higher, and then we the next sort of phase of it was multiprocessors, and all of these technologies together have really caused this increase in our capabilities to continue going upwards, ever upwards.
Is there a natural
There
limit
was
to
a
this?
time.
Is there a ceiling?
Yeah, well, I believe, yes, there are physical limits. I mean, once you get down to the size of an atom, you can't really go any smaller. So there is a physical limit. So there's obviously the physical limits of the speed which electromagnetic signals can be moved around. So there are physical limits, but the human mind is very ingenious, and there are ways to sort of continue this trend. I think it's going to carry on for a long time. But interesting that you should mention that, because again, going back to around the 90s, when you bought a new computer, you talked about the chip speed. It was always, oh, I'm gonna, and there was a period in the 90s where, I remember when the first 1 megahertz machine came out, and it was amazing. You could now have moving video on your screen, and then it was 1.5 megahertz, and then 2 megahertz, 3, 4, 5, 6. It carried on. Now I don't even know what the chip speed is in my laptop. I don't care. I don't know. Probably you don't know either, and it's because those have more or less hit a physical limit, and capabilities are expanding in other ways. I mean, the sort of latest trend is GPU processors. So my new laptop that I'm speaking on right now, I just got a few weeks ago, has something like 16 CPUs and 12 GPUs, something like that.
Yes. And then it's also the thing is that you move a lot of the computation into the cloud, right? This is also a new way to get around the Moore's law in a sense, right? You can run massive computations in the Google Cloud and Amazon Cloud pretty quickly.
That's right. So yeah, and for these very big large language models that are all the big trend right now, yeah, they're basically computing them on tens of thousands of machines in the cloud. you know.
Well, that's what makes Llama very interesting, right? Because you can have this you for $600, I think, you can train a model on your laptop that does quite well compared to these very massively trained models. How does that work, and why does that work?
Well, I think I would agree to disagree with you that they work quite well, Be- because I have been playing around with a lot of different models, and in my opinion, really OpenAI's models are actually superior to anything else out there by quite a lot. So yes, it is getting there where you could train your own models, but in my opinion, they're quite far away. They're quite far away from the pre-trained models that OpenAI has as well. Hugging Face is, of course, a big player that has lots of pre-trained models that you can download or you can use via API, and I commend them for that, and it's a great resource. But the performance is in my opinion, not even up to OpenAI's models. Llama, I haven't specifically looked at that, but to your point, and to you know to the whole Moore's law thing, within a decade, we are going to be able to train models comparable to GPT 3.5 or GPT 4 from an OpenAI on our laptops. If Moore's law holds, and it is holding, and it's been predicted to not hold many times. But as I say, we've found other ways to make it continue. So if it does continue within a decade, we will be able to train, models with the same power on our
So that
laptops.
brings me kind of to this question like I would have for you in terms of, Ray Kurzweil claims that there's a strong relationship between intelligence and Moore's law, right? So if we have this massive compute increase, we can then build more and more intelligent things on top of that. Do you agree with that? Is that even intelligent? So is GPT-4 or any of them, is that intelligence? Would you describe that as a type of intelligence? And is that correlated with Moore's law? Can we just make things arbitrarily intelligent over time?
The My short answer would be no, but let me give you let me give you the long answer. So, and you and I have spoken about this before informally, and so I, in my opinion, the entire community and the public in general always forgets what the A means in AI. We always concentrate on the I, and we forget about the A, right? So, I to me, the goal has never been to create intelligence. After all, we cannot even define intelligence. There's no like definitive definition of what is human
Yeah, but that's
intelligence.
true of
Do we?
computers too, right? You can't say, what's a computer? We built some. We built some, but we don't really know how to define them. It's similar to the state, right? We have a state, but define state. I mean, that's impossible, right? So Karl Popper says we shouldn't even engage in the exercise of defining things too seriously. So you define something for a particular argument, and then for the rest of the conversations, that definition doesn't even have any applicability. You just keep it within each argument, right? So you just like define it on the fly, then you drop the definition. That's sort of his attitude toward it, and I kind of agree with that, because we know we can build a state, but can you really define what a state is? Is it even point?
I
Is there a point to that?
well, I think. Well, so you said we can't even define what a computer is, and I would say that you can. There is actually a formal definition of what a computer is, and it's defined as something which was defined abstractly as a finite state machine of sorts, which has this infinite tape, where you can have different instructions on the tape, and you can move the tape read ahead, backwards, and forward. So there is this formal
But then there is
definition.
no such thing because my computer doesn't have a tape. I don't know if yours does.
No, no, it doesn't. It doesn't use a tape, but it does have memory, and it is capable of reading a specific point in memory, and that sort of
But
is
I
the
can do that too. So I
equivalence.
am a computer in that sense, right? So that's where it gets so ambiguous.
In that sense, in that sense, yes, you could manually be a computer, but a computer is different to intelligence, right? So
I'm
what
just
we
saying that the exercise of defining things is sometimes a little bit defining poverty. You know it when you see it, right? Poverty is a great example, right? I mean, how do you define it, right? It's like it doesn't necessarily mean what people would like to define it as the lack of money or something like this, but that's certainly not true, right? There are people who are not poor who are missing money at the moment or maybe for some time, but there's it's extremely elusive when you get down to it. I think it's true of the state of love, of any kind of concept that really carries some important meaning. The definition is not so clear. So I'm just saying, because we can't define intelligence does not necessarily mean we couldn't build it, right? And I agree that it's very difficult to define intelligence, what it means, and it means different things in different people's minds.
it does. But sort of getting back to your question about it, I think, you know, to me, there's a difference between intelligence and artificial intelligence. I think that the A, getting back to it, is very, very important that we tend to forget, because you could build something useful that wasn't necessarily mimicking or wasn't necessarily truly intelligent in the way that human beings are, or the way we
Right,
think
right. So
we
that
are, right?
comes down to the
So
kind, right? But that reminds me of that
yeah,
paper by Thomas Nagel, being a bat, right? So consciousness is similar to intelligence in that
yes,
sense. My consciousness, I'm conscious, but I'm conscious in a different way than a bat would be conscious. So you could similarly say intelligence has similar kind of properties, right? You can be intelligent like a human, you could be intelligent like a deer or a whale or a dolphin or any other kind of thing, or maybe a machine could be intelligent. I'm not sure, because
yes.
do you think that formulating your own goals would be part of intelligence, or is it a necessary thing of intelligence? This is something I've been debating with myself. Do you have to be able to formulate your own goals and satisfy your own needs and wants? In which case, there's no way that a machine can be intelligent, right? Because
I I would tend to agree with forming your own goals as being part of human intelligence. I think at least that seems to be, it should be in part of the definition, and in that sense, I would agree with you that artificial intelligence cannot do that. You know, if you remember, there was that engineer at Google who got fired, and then maybe he got rehired, where he claimed that. I mean, we're talking here a little bit about
yes,
sentience,
yes,
right?
also, these are all mixed in. I think they're not exactly the same thing. So sentient,
Yeah.
because sentient bacteria is sentient, probably. A fetus is certainly not very intelligent. So I think you can be sentient without intelligence, or with less intelligence, lower levels of intelligence. You can be conscious and absolutely not be thinking, right? So I think, for example,
Yeah.
Buddhist monks will say that your consciousness is heightened when you turn off your mind, which means that
Mm-hmm.
intelligence and consciousness would be anti-correlated in that sense, right?
Mm-hmm.
So because any form of intelligence would be part of the monkey mind that makes you think about objects and manipulating things in your mind. When you meditate, you let all these things go, and you start trying to become empty of those things, right? So then, if it's true that someone who meditates has a heightened consciousness, in that sense, it would be exactly going against Ray Kurzweil's thesis, which is that consciousness is part of the computation, or it comes out of computation. I had this discussion with Uptal Chakrabarti on the show, actually, about exactly this topic, who also agrees that computation and consciousness are two separate things. And so sentience, I think, is yet another
Yes.
thing, is about life, right? Is something alive or something dead? You could say a strand of RNA might have sentience, but probably not much intelligence, a little bit.
Yeah, I would tend to agree with that. Those are all three of those things are different, and you know, even today, researchers, philosophers, other people from other disciplines can't agree on definitions of those three things. And uh, I think one major difference is between humans and AI is that we can talk we can talk about intelligence. We can talk about talking. We can talk about talking about talking. We have no limit to the levels of meta abstractions that we can sort of go to. And this is definitely absent. Again, if you go to sort of ChatGPT, people do ask it philosophical questions, and you've seen these memes, you've seen these answers being, becoming memes and going around, which makes it look like it's sentient in some sense. But I, I think by most definitions of sentience, it won't be there. I'm sure you're aware of Lex Friedman's podcast, and he's somebody that I have great respect for and love his podcast and would agree with him probably on 95% of things. However, where I don't agree with him, recently he had one talking about this very topic where he suggested that he thinks that ChatGPT does have sentience. And his reason for that, I can't remember who he was talking to because he has so many episodes that come out. But when asked, why he thought that, his reason was because it seems like it. So, so, so I think he's missing the A again there. Just because something seems like something, it doesn't mean
But
it
the great
is,
Alan
right?
Turing, that's what he put forth. It's a test for it, right? So this is the thing. You got to talk to it and see if you
Yes.
feel like it's conscious. If it is, then it is. But I, of course, disagree with that now. But of course, that's easy to do in hindsight. But now I'm looking at this thing and I know how it's produced, more or less. I don't know all the details of how
Yeah.
ChatGPT is produced.
But even by that definition, I think we're not there yet because I got an email the other day from a colleague of mine, and by the time I got to the third line of it, I was already suspicious. I could tell there's just something about it that you can sense that, and this came from an LLM, and specifically he had got it from ChatGPT, and I said to him, "You didn't write this, did you?" And he sort of laughed and he said, "How did you know?" And I said, "Well, first of all, I recognize. First of all, there are no spelling errors in it." And
Well, okay, spell check. You can probably.
he tends
I
to.
see.
So, but that was more contextual. That was more contextual clue for me because I know that he makes a lot of spelling errors and he doesn't run spell check. But even apart from that, the structure of the sentences, the way the sentences flowed was very uncharacteristic of him. So I could tell. So by that definition, it didn't pass the Turing test. Now you might push back and say, well, that's just an example of one specific person I'm
Yeah, because
referring
you're not
to.
actually testing consciousness.
But
You're testing whether it was that
well,
person or something else, right? Not necessarily whether it's a sentient thing or not a sentient thing, but rather it's
yeah,
that friend of yours or not. So that would be different, I think, fundamentally. But at the same time, I can tell too because it does use certain phrases all the time. It would say things like "we're going on a journey of AI," or if I wanted to, I played around with it enough that I know that it would say things about journeys. It would say things about delving in. It would use certain characteristic phrases that it just can't get away from. It seems. And even when you try to say, "Don't use this," I tried this. Don't say "delve in" and don't say "going on a journey." It will still sneak it in somewhere. It will take it out of that particular place, wherever it was before, and it will stick it into some other place. It just seems to be incapable of escaping its own little metaphors and its own sort of patterns. There's a certain patterns that you can tell still. But I think,
right.
that's probably something you can fix within short order, I would say. And you pretty quickly might arrive at something that passes the Turing test. I mean, there are definitely different things that claim to have passed it,
Yeah,
whatever it is, but that test is
sure.
obviously flawed, right? And could you tell me a bit about why is it flawed? What is exactly wrong with this test, and is there a test that could actually get to
Well,
it?
well, I, I don't know that there's anything wrong with it. I think what he proposed, I actually think it's quite good, but it again goes to what is our definition. And I believe his that was his test for intelligence, not for sentience.
I thought it was consciousness.
I don't know that he
I
had.
thought it was conscious.
Was
I
it
think
for
it was
consciousness?
consciousness. It was sentience. Yeah.
Okay. Yeah, a different thing. Yeah, I mean, going back to sort of the bat story, right? By that, by some definition, it is a good definition, right? And I don't know if we'll ever even have a proper definition. It goes back to how do we even define
No, right. Or
intelligence,
consciousness. Any of these things.
or consciousness, or this idea that in fact maybe sentience is just an illusion, maybe
Yeah,
the ability to. Yeah,
I've
I
heard
mean,
that before. Daniel Dennett is a proponent of exactly this. But when you
yes,
interrogate
yeah,
these people who say that, I feel that in the end they always behave as if they really truly assume people to be conscious. They don't seem to be able to get away from this.
yes.
It's it
But what does it even? What does that
yeah.
even mean? What does it mean to assume that somebody is conscious? I don't know what that
Well, so
even
I
means.
I guess the way that John Searle and others would put it is simply, I guess, a working definition of consciousness is that there is a subject inside of you somewhere, where I don't know, but there is something inside of you that when you feel the wind on your face, there is a you there that feels there is some body or some receiver of experiences, and that would be the conscious field, right? So you go through a cornfield and you feel the wind on your face. There's somebody feeling this wind, right? ChatGPT doesn't have that somebody feeling anything. It can say that it feels the wind on its face, but it has no face.
Well, I mean, yeah. What about a wind meter? A weather instrument that measures wind speed. That can feel
Does it
wind.
feel it? Does it?
And
Is there something there that
well,
feels it, or is it just an instrument that can tell you? I took a reading over here.
I mean, you're right. That is a good question. But then you could just ask, well, maybe the brain is also just an
It
instrument,
surely
right?
is. It surely is. But it does seem to produce an experience of something. You see, I guess the way people put it is consciousness is about there being something that it feels like being. It feels like there is a way that you could describe how it feels like to be Neville Newey, or there is a way that you can describe how it feels like being Johannes Kastner, or a bat, or a horse, right? Those are those a horse has this experience of what it feels like being a horse, whereas I don't think ChatGPT has an experience of what it feels like being. I think that doesn't even make sense. It seems nonsensical the moment I start saying it.
Yes.
And I think
Yes.
that's the
No,
definition. Anyway,
I would tend to agree with you. I mean, it does it, but it is fluid as you've suggested because as you start moving down the sort of the animal chain, let's call it. So yeah, we sort of think dogs and horses and other higher mammal, specifically mammalian life forms. We sort of do think of them as being conscious and even sentient and God forbid we bring the word soul into it,
oh yeah,
right? but
yeah, I
but
think that's just
but
trying
then
to describe the same thing, right, with another word. Soul, I think, is an older
yeah,
word.
yeah,
Consciousness is a newer word, but I think it comes to the same thing, right? What
yeah.
they meant by soul back then, and it's interesting because Descartes even used this concept of consciousness. When you look at the actual French, it says, "I am conscious, therefore I am." I cannot doubt this one thing, and that is that I'm conscious. I can doubt everything else. I can doubt that you're conscious, that you even exist. I can doubt that this room exists, or that there is a world out there. but I can't doubt that I exist because I'm conscious. And that's essentially, and now people like Ray Kurzweil and Daniel Dennett seem to turn this on its head. They try to say that they can actually doubt themselves to be conscious, which I think is kind of I don't really buy it.
It's almost circular.
How can there be a world
Yeah,
if no one can be conscious of it? Like consciousness essentially is necessary
yeah,
for anything to exist, I think. It is an absolute
yeah.
fundamental necessity. You cannot possibly doubt it. And therefore, I kind of find this whole mind
Well,
uploading and all of these things kind of silly. But what do you think of that? Mind uploading or forking
well,
yourself off, as one of
I
my guests put it.
well, I, I don't know about that, but you know, it does raise, this whole question is very interesting to me because, okay, we kind of generally agree that the higher mammals have it, but what about reptiles and birds? Now it starts to become less obvious then, and you've been to my place, I think, in the time that I had guinea
Yes. Oh, you
fowl,
don't have them
so.
anymore?
I don't have them anymore. They all got eaten by predators, so they're no longer conscious. But were they ever? So I observed these birds, daily. It gave me great pleasure to sit. You've been to my place to sit outside and watch these birds, and I watched their behavior. And after a time, I came to the conclusion, thinking about their minds and how they interacted with each other and so on, I came to the conclusion that these birds are running on an algorithm, purely on an algorithm. Now, I might not be correct about that, but it seemed to me that they essentially are reacting to their environment and to the signals they're receiving from the environment in a very specific way, and that's all they seem to be doing to me until they died. Now,
But
I'm
does that
not
contradict
convinced
consciousness?
that.
Because I think we're running on an algorithm too. We have drives, right? We want to survive. We want to somehow have children. Why do we want to have children? Well, that's programmed into us. It seems that there isn't a choice. It's an illusion of choice. So I don't believe necessarily in free will. At the same time, I believe in consciousness. So this may not be necessarily contradictory. I think that they're running on an algorithm. I think evolution is an algorithm. So everything runs on an algorithm from that perspective. And I just think that, okay, this algorithm that makes me do the things that I'm doing is very predictable, because that's how Facebook predicts what I'm going to do next, right? And we all are kind of, you know, it's sad to say, but we wouldn't want to think of ourselves as that, but we are quite manipulable, predictable animals, right? And I think that the free
Yeah,
will is actually kind of an illusion. I do think that. I think we have the freedom to choose what we want. I think Albert Einstein, or was it Schopenhauer? I think Schopenhauer said that. We have the freedom to choose what we want, but we don't have the freedom to want, to choose what we want, right? Like in a way that we can fulfill the things we want. We can fulfill the desires and the things that are coming our way by taking certain actions, and we have that freedom, but we can't actually choose our desires themselves.
yeah, that's interesting. And again, I would ask: does that flow down to the lesser life forms? And you mentioned bacteria earlier, or what about viruses and bacteria and very, very, very primitive life forms? Does it translate? Or is a virus conscious?
Yeah, I
I
think
don't
this is
know.
becoming harder to say, right? Because I think that about a dog
Yeah,
or a llama or a horse or a cow, I would be very, very confident that these are conscious, because simply their physiological, their machinery, their brains, and their bodies are
it's
rather
very
similar
similar
to
to
ourselves.
ours.
I
Yeah,
know I'm conscious.
yeah,
This thing is built very similar to the way I'm built, and it's coming from the same evolutionary pathway, right? It's very likely that it must be conscious. But when it comes to grasshoppers and butterflies, they're evolutionary rather far away from us, and so it's difficult to say. I can't really, I think a bat is conscious, because similarly, it has a little brain, and I think even your guinea fowl, I think they're conscious because they have little brains that are smaller than ours, but are in every other way similar to ours.
Well, a grasshopper also has a brain, but yeah, but it's interesting that yes, they're evolutionary very far away from us according from our reference points, but nevertheless they share some amount of DNA with us. So, even mushrooms, share some DNA with us, and in fact, we are closer to mushrooms than we are to plants. So, if aliens, if such things exist, and at this point I assume that they do. I'm talking about intelligence. There's that slippery word that sneaked in again. But if intelligent aliens do exist and they arrived on Earth, would they say that we are that far away from grasshoppers? We're probably closer to grasshoppers than they are to us, right? So it's the reference
No,
point you take
I
to
think it's
define
very plausible
evolutionary
that they are also conscious. In fact, if you ask me what would you bet on, I would bet that they're conscious rather than that they're not conscious. Similarly, as if you ask me, are you willing to bet that your cell phone is not conscious? I would say yes, I'm willing to bet that my cell phone is absolutely not conscious, but that the grasshopper is.
right.
Whereas, but I am further away, like, my confidence in the grasshopper being conscious is much lower than my confidence in a horse being conscious, for example. But I want to,
So there's a
but I want to move on. I want to also kind of cover a little bit on the future of data science and the future of AI and where you see these things going. Are you alarmed as also Sam Altman is alarmed or said he's alarmed, but then he says that he wants regulation for AI, but then he says if the European Union does too much regulation and it bites, he will leave the European Union. So the same guy says it's a little bit confusing what he means, whether he's really alarmed or he's just doing this out of some kind of incentives that he has for saying that. What do you think about it? Are you alarmed? Are you worried about it? Do you think it's going to make us more productive, happier, healthier, wealthier? Or do you think it's going to do that plus something else? Or what is your view on this?
I'm not alarmed. I'm not alarmed at all, and I see articles coming out daily where it's fear, trying to inject fear into the public, and everybody's going to lose their jobs because of ChatGPT. I even see it amongst data scientists and that, but I think that it's all incorrect hype. If anything, when this whole sort of and it is a big milestone. It is a big milestone, even though it's not truly intelligent. But the whole emergence of LLMs in the last 2 years, 3 years or so is certainly is a big milestone. But I see it as an opportunity. I see it exactly the opposite of being alarming. I just in the own models that I'm building for you know, various clients I have and so on, the quality of them is just so much better, and you can do so much more. Using embeddings, for example, that you can get from OpenAI. So to me, it's the opposite of alarm. I see it as a new opportunity, a new area of opportunity. Having said that, I can see how it could potentially be harmful, and in sort of the same way that everybody seems to agree that social media, for example, has been harmful. But the way I sort of like to think of it is, if you think about cars, right? If you think about automobiles, there was a point in time when they were incredibly harmful, and it's taken us 100 years to sort of get where cars are pretty safe right now. And I'm not only talking about safety in terms of collisions and accidents. I'm talking also about emissions control and the air quality and so on. And if you think about it, it wasn't that long ago, in the 1970s and possibly even in the 80s, you would have heard that you couldn't walk on the streets in LA because because of the exhaust fumes. I visited some big Asian cities in the 90s, like Bangkok and Jakarta, and some of those places where I'm asthmatic and I could barely walk in the streets there. It was so, and I don't know if you go there today what it's like today, but
LA has gotten cleaner over
my
the
point
last
is that
30 years for sure.
it
The time was there,
absolutely
yeah.
has gotten cleaner, but California has like very strict laws about emissions. But my point is that any technology can be harmful in its early stages, and then we sort of, as it evolves, we get sort of more regulations, and some people understandably hate those regulations, but they sometimes can do do good for humanity in general. I think exhaust emissions control in cars, for example, was a very good thing. Some people might disagree, but it's certainly made the air cleaner and more healthy. And I think we're at if you look, and that's 100 years later. I mean, when were cars invented? We're 120 years later. It's taken for us to get to this point. Things like ChatGPT and the dangers that are being proposed. Yeah, probably some of them
Like
will be
which one are
harmful.
you
But
worried the most, if there is any one that can you sort of rank them?
well, I think what's a little bit alarming is people students submitting essays that they didn't
Oh, really?
author
This is one you're worried
themselves
about. I'm
and
actually not worried about this one at all.
well, I don't know if worry. I don't know if worry is the right term. I mean, it's. We have to work out what are the protocols behind that, because if we suddenly produce, a whole generation of students that have never ever written a single thing, is that is that good or bad?
But it can't really
Another.
write
I
its
mean,
own
it's a
essays, right?
similar analogy.
You have to prompt it, you have to change things, you have to constantly be in dialogue with it to write something decent, right? So it's not a really, I mean, I mean, what about this? Okay, I've thought about it and I thought, isn't this similar to the calculator? The way the calculator was introduced, at first everybody was, oh, we can't let people use them in the tests. And why wouldn't you? Because in reality, when they're going out there and they're doing their
Yes.
whatever accounting jobs or not, whatnot, they will use and they should use calculators. In fact, they should maybe schools should be
Yeah.
about learning how to use ChatGPT better to write more interesting essays and instead of
Absolutely. I
yeah.
understand it.
So
Yeah. I mean, that's, going back to your question about was it alarming when these things came out? Uh, No, and as I said, I wasn't alarmed. I saw it as a new opportunity, and already that opportunity is showing itself. At that time, I thought, well, this is certainly going to create new types of jobs, and already, if you look around the literature, already there's a term that's come out which is called prompt engineering. Now, prompt engineering, that term didn't exist 5 years ago, 4 years ago, maybe not even 3 years ago. But now there's a whole science that has come up around prompt engineering, right? So, what is prompt engineering? Prompt engineering is precisely what you say. It's how you would construct your prompts to get something useful out of
I
an
was telling
LLM.
Ben Legg,
You know,
I had a conversation with a couple episodes ago. I was telling him that he was asking me, "Do you think that it's going to change programming completely?" And I told him, "I think that people will program in English instead of in Python and in Java, but in general, you still have to program, right? You have to know what you want to get from the machine, and you have to be able to tell it exactly." In a way, what it is that you want, right? And what are the outcomes you want? Maybe you have to do some test-driven development, but you'll still have to essentially tell the machine what it is that you want. That I think I just call that programming. I mean, prompt engineering, isn't that just the new programming?
well, I think part of it is, yeah. You might create a prompt which is programmatic in nature. Sure, there's other parts to it. For example, you could create a classifier without writing a single line of code by saying to, for example, you could say to GPT, in which of the following categories would you place this item? Is it A, bird, B, a dog, C, a
Right,
horse?
but then you have to show it the horse.
And give
How
it.
do you do that?
Well. Remember that OpenAI also has, Dell-E. So Dell-E is also one of their offerings, and there are like we have large language models, we also have large image models, so a combination of these things. But it could even be a piece of text. You could, for example, let's forget about images for the time being. You could even say, what what does the following text describe, and then give a description, and then you could, and that's kind of prompt engineering in a sense. So you could build a very simple classifier simply by actually building a prompt. So in that sense,
That's
yes,
really
you're
interesting,
right.
right? Because
It is in a
it's more of an
way,
open world kind of classifier as opposed to traditional classifiers where you have to give it the 10 categories that it has to make a prediction on which one of these 10 things it is. It seems that ChatGPT is able to classify n things, classify a thing according to n things, which is n is completely open, right? It can you can feed it a piece of text
yeah,
and what is this about, and it can say something that it's never said before. It can give it a new label, and it can understand completely new
yeah.
things. In that sense, it's actually a better classifier, or is that worse because the explosion of labels that you might get from it?
Yeah. Well, certainly the part of the prompt engineering is to try to control those labels. So if you have a very specific custom set of labels, I at this point in time, I've been experimenting with this quite a lot recently, and it's still, in my opinion, better now to just use the embeddings and build a traditional classifier, but using the embeddings as features rather than trying to do an NLP way of doing it, because as you say, you're gonna get
Could you
possibly an
could you tell the
explosion
audience really quickly what an
of
embedding
categories.
is? Just because I think people who are listening, watching this, don't necessarily know what it is. Could you just give it a quick explanation?
Yeah, yeah. So fundamentally, all computers really are dealing with numbers, right? So even though we might think of an NLP problem as dealing with text, the algorithms and so on, sort of at the level below that, are all in or basically numeric. So an embedding is just a numeric representation of a word, and typically it's not just a scalar. Usually it's a vector, what we call a vector, which is you know a higher dimensional space of scalars. So an embedding is really a numeric representation of some text. It doesn't have to be a word, it can also be an entire document, but it's some representation that within that vector space contains some meaning. So two and these have even become multilingual now. So two documents that are describing perhaps the same thing, but in very, very, very different words. In good embedding model, they would come out with a very similar embedding, and in fact, that is how you would know that they describe the same thing, is because they would sort of have vectors that are in that vector space some small
So
distance apart from
ChatGPT,
each
when you
other.
go to the API level of it, gives you these embeddings, right? So if you feed in a document into it, it can give you back an embedding in the API version of it. Is that right?
Correct, absolutely correct. Yeah, and they have a lot of different embedding models. And these embeddings, they can get very, very sophisticated. I believe what they call the Da Vinci model of embeddings gives you vectors that are around 11,000 dimensions. So this is a massively huge sort of vector space. So you can get quite sophisticated, and it brings us back really to the thing about how the A in AI. I don't really believe that inside our brains we have embeddings in the sense that we have a vector space that we kind of compute in. If you show me two pieces of text, I can tell you that if they're describing the same thing,
Sure, but I mean, you
even
would
if
agree
they're
that
in.
a bird and a plane and a butterfly, they all fly, right? So it doesn't really necessarily matter how a butterfly flying, when a butterfly flies, it being different from a bird or from a plane. What matters is that it functionally does the same thing, right? Don't you agree with that? I mean, so the exact implementation of how intelligence works, I suppose, that's kind of part of this AI thing, right? Is that we can produce intelligence by loosely basing some things on the brain, but not going too close to it, not having to really go, rebuild something like the brain in order to build something that can take inputs and convert it into outputs the way that the brain, or you know, basically mimicking the outputs from the inputs that the brain would produce, but in a completely different way potentially. I think that wouldn't matter, right? Or do you agree, or do you think it's
Yeah, no, I think it doesn't matter. I mean, there's a practical use regardless of how it's done. My point was more the way that we're doing it with AI is it's I'm talking specifically about tasks that use these embeddings. I think that's very far away from the way that humans doing it. But again, the A in AI is very, very
it is.
important.
Although for me, like, what do you think of this? I wanted to relabel it as an augmented intelligence, because I don't think, again, because of this consciousness element, right? So if you don't have a thing being intelligent, because there is no thing in itself, there's just there is no internal anything to it, right? There is no machine that's experiencing itself. There's no self there. So wouldn't it be smarter to just say, because it always augments our own intelligence, right? It does something for us. It does something for some human who's asking it to do something. Shouldn't we call it augmented intelligence? Isn't it ultimately just augmenting our own intelligence?
Yeah, I agree with you. The name is probably the name AI, artificial intelligence, has probably caused a lot of misnomers. I would even propose that you go further than that, and you take out the word intelligence, and maybe call it augmented cognizance, or augmented thought, or augmented reasoning, or something that
I've
takes
actually
away the
heard this
word
cognitive
intelligence, since we
services.
can't really
I've
even
heard this term before, cognitive services. This seems to make a lot of sense. It's a type of cognition, so process.
yeah, or reasoning assistance, or assisted reasoning. How
I
about
like it.
assisted reasoning? Or I like the A turning into assisted, because it
Yeah,
really is assisting us to accomplish something.
I agree.
So
One
yeah,
more thing I
I
would
don't know.
really love to get from you is, like,
Assisted knowledge.
how do you see the future of data science? What do you think a data scientist will do in 10 years from now? What will this job be? Will there be such a job called data science? And yeah, so I guess,
Yes. I absolutely, there will be a job called data science, and I'm not sure if it will be in 10 years' time, but there'll come a point where perhaps it will be the only job. I think we might all become data scientists if we get this assisted knowledge, or whatever, we assisted intelligence, whatever you the term you're going to use, and if it becomes so powerful, and if Moore's law, if let's assume that Moore's law also applies to AI, it's going to, it's, I believe it can be for the good of humanity, and we're going to go through this dirty patch like we went through the 70s with the the air quality problems with automobiles. We're going to go through that. So maybe it will take longer than 10 years. Maybe it'll be 20, 50, 100, who knows, right? But certainly it's eventually going to be for the good of
I
everybody.
really hope you're right
I
on this, and I hope it doesn't take so long. I hope we can get our act together faster, because the path to it could be quite painful, right? If it's not done right. It's
Well, look how long cars have taken us, and
yeah.
cars are far simpler
Maybe we
things.
can do better
So
this time around, because we can learn, right? I mean, I know that Hegel said that one thing we can learn from history is that we don't learn from history. Have you heard that? I hope he's wrong on this. But yeah, one more thing. Can you tell the audience something that they should take home with them from this discussion? How can they stay in touch with you? if they're interested in talking some more to you about these topics, or learn about what you're up to.
Well, I assume you can put my email address on the on in the notes of the podcast. And I mean, if I'd want people to take away anything from the conversation, is don't be alarmed, and be optimistic. I would say I I'm very optimistic about what it can do for humanity. So I read the alarmist articles, but don't take them for their word. Remain positive, and you know stay happy.